Alright, here we're looking at section 10.1. In our learning targets for today, we're going to identify special segments and lines, then we're going to draw and identify common tangents, then thirdly we're going to use some properties of those tangents. Now remember, in this chapter we're only dealing with circles and different parts of circles, so we're always going to compare these back to what we're looking at. So the first core concept is just some parts of a triangle and parts that we're going to be looking at. So we should know that the diameter of a circle goes through the center, and it's the longest piece across the circle. A radius of my circle goes from the very center out to the edge, and it's the same. The radius is the same in the entire circle. So a chord is a segment whose endpoints are on the circle, right? But it doesn't necessarily cross the center. So a diameter is a special kind of a chord because it touches both ends of the circle, but it also goes through the center. So these are all just dealing with some segments. So a secant is a line, right? And you'll see that it continues in both directions. So a secant intersects my circle in two places, where we can see here. So a tangent line is, again, a line that's next to my circle, but it touches in exactly one place. And that's called my point of tangency. It's the point where the circle and the line meet. So now first we have to figure out whether the line, ray, or segment is described as a radius, chord, diameter, secant, or tangent of circle C. And this is just how we label circles when we're talking mathematically. So first I want to look at segment AC. And I know it's a segment because I don't have arrows on the top here. So I'm looking at segment AC. So from here to here. Well, I see that one of my endpoints of that segment is on the circle and the other one is at the center, so I know that that is a radius. So now let's look at segment AB. Again, it's a segment because there's not arrows on the top, and I see my endpoint is here on the circle and my other endpoint is also on the circle. So it is a type of a chord, but this is my special chord because it does go through the center. So that's my diameter of my circle. So now let's look at ray DE. So a ray, remember, starts at an endpoint and continues on in the other direction, right? And I know it's a ray because I have one arrow here. So if I start at D and go to E, I see that I'm not going through the circle, but I'm touching the circle at one place. So it's tangent because I intersect at exactly one point. So now let's look at part D, line AE, and I see it's a line because I've got those arrows. So I see here's A and here's E, and I'm going through the circle, touching it in two places, so I know that that is going to be a secant line, right? Because it continues on in both directions, but it still touches in 2 points. So now I want you to go back and look at what these other things, how you would describe them. So here's our next core concept. We're dealing with coplanar circles. So when we see the word coplanar, that means I've got two circles, two or more circles, that are on the same plane. So we can either have these two circles that slightly overlap and touch in two places. They can touch in one place where, again, they're tangent. And whenever we see the word tangent, that means we're going to be touching in one place here. Or we can have no intersection points where they're either not touching at all or one is inside of the other. So these are just some ways that we can look at coplanar circles. So here for this example, we have to tell how many common tangents the circles have and draw them. We want to use blue to indicate common external tangents, right? External, outside, and red are going to be my internal tangents. So I want to first draw the segment that joins the centers of my two circles. Then I draw the common tangents. Okay, so I'm going to use blue to show the lines that don't intersect the segment joining the centers, and red to show the lines that do intersect those. Okay, so in A I have 4 common tangents, right? So I draw my line from my two centers, and then I find all of my tangents. So you'll see these two lines. This top line touches both circles at exactly 1 point. And this blue line down at the bottom touches each circle at exactly 1 point. Then these red ones also touch each circle at exactly 1 point. But these cross through that line that connects the centers. So that's why they're red. But here I have 4 common tangents. So let's look at B. In part B, I only have 3 common tangents. Again, my two blue, my 2 external tangents. But here I only, since these circles are touching, here I have 1 internal tangent. So now let's look at part C, where I have 2 common tangents. And so here it's just my external tangents. I don't have any internal tangents because that would cross my circle in more than one place. And that's not a tangent line, that's a secant line. So here we just have to find everywhere where it touches both circles exactly one time. So now here's a couple that I want you to try out and see how you can do. So you'll notice that you're given the center of the circle by the black dots. So here they're not overlapping at the center, and here, since there's only one dot, they overlap at that center. So see how many tangents you think that they have. So now here's a couple of our theorems that we're looking at. So the first one, that I know that if a line is tangent to a circle, if and only if the line is perpendicular to the radius. So that tells me that it connects in exactly one point if it's perpendicular. So I can always look at the angle to help me determine if it's tangent or if it's not. So then my second theorem that I'm looking at is the external tangent congruence theorem, which tells me that if I have two tangent segments, and so from the same point that are tangent to the same circle, those lengths are the same. So here I have my circle P and this point S that's outside of my circle, and I see I have two tangent segments from S. I have segment RS and TS, and they're both tangent. Those lengths will be the same. So now we're going to look at some examples with those. So here I'm asked, is ST tangent to this line? Now remember from that last page, I know that it's tangent if this is going to be a 90-degree angle. So I can go ahead and use my Pythagorean theorem to set it up. So 12 squared plus 35 squared equals 37 squared. And figure out, is this mathematically true? Which it is. So I know that this is a 90-degree angle, so it is a tangent line. If you end up with this as not being equal, then you know that it's not a 90-degree angle, so it would not be tangent. So here in this next example, in this diagram, point B is a point of tangency. So I'm told that this is tangent, so I know for a fact that this is going to be a 90-degree angle then. So now I can go ahead and use my Pythagorean theorem and set that up. One thing I have to note is that the hypotenuse of this triangle is going to be 50 plus the length of my radius. So I have to include that as well. So I've got my hypotenuse, which is AC, and my two leg lengths. Then I can substitute in what I know and what I have. Then I go ahead and I multiply this out. And when I have this r plus 50 squared, I cannot just square the first term and the last term. I have to actually multiply it out. So I end up with r squared plus 100r plus 2500 equals r squared, and then 80 squared is 6400. So now I can go ahead and subtract this r squared from both sides and kind of simplify. And then I also subtract this 2500 from both sides. So now I'm left with 100r equals 3900. And then I solve for r, which is 39. So the radius of my circle is 39 feet. So I look back at my original problem to see if that even makes sense. Well, I see that this length is 80 feet, and this is 50 plus some feet. So 39 would be an accurate representation of that length. So we can also construct a line that's tangent to a circle. So there are some steps that we have to do that. So here we're looking at circle C and point A is outside of my circle. So using only a compass and a straight edge, I can actually construct a line that I know is tangent to my circle. So the first thing I have to do is I have to find my midpoint of AC. So I connect the center of my circle and my point outside. Then I find the midpoint, and I can do that using another separate construction. Once I have that midpoint, I draw a circle from that midpoint, okay, using the length of the radius of MA. So then I can construct my line where these two circles meet, which was point B, and that point that's outside. You may or may not have to do this later on, but it's a good thing to know how we can construct these things using just compasses and straight edges. So now here's example number 5, using those properties of tangents, right? And this is our other learning target. So I'm told that RS is tangent to circle C at S, and RT is tangent to circle C at T. Find the value of X. Using my theorem, I know that since they're both tangent to the same circle from the same point, my RS, segment RS, is going to be equal to the segment length of RT. So now I can go ahead and substitute what I know here. So I have 28 equals 3x plus 4. So then I just solve for my x by first subtracting 4, and then I'm going to divide by 3. So I end up with x equals 8. And I can look back and see, was I asked to find the length? No, I was just asked to find the value of x. So now that I have the value of x being 8, I have finished that. The biggest thing to remember is that when I have a point outside the circle and two segments tangent to the circle from that point, those segment lengths are equal. So now here are a couple problems that I want you to try on your own and see if you can kind of follow the steps that we've been doing as well. So now let's look back at our learning targets. First was to identify special segments and lines, and that's really what this is looking at. The difference between a chord and a diameter, what we're looking at for the radius. How is a secant different than a chord? What do we know about a tangent line to my circle? These are the big things for that first learning target. Then we were to draw and identify common tangents, right? We have both external tangents and internal tangents. And remember that a tangent that's common to two circles crosses each circle exactly once. And then we looked at the properties of tangents. And the big property that we looked at is knowing that a tangent is at a 90-degree angle to my radius, and that also if I have a point outside my circle, two segments that are from that point tangent to my circle are the same length. So now that we've looked through these learning targets, go ahead and start working on your homework for 10.1.